We talked about the main board and how the main board has these things called expansion slots. Right? This is to say that different kinds of circuitry can be placed in these expansion slots, and also they also have slots for memory and etc. Right? For example, the RAM will be slotted in somewhere here, for example. Right? And needless to say, you can slot in as much memory as the motherboard can handle, and as much memory as your OS can handle. Right? Sometimes you can put in 32 gigs of memory, but if your OS cannot handle it, if your OS has a maximum of 4 gigs, then it will only recognize 4 gigs, something like that. So there's a limitation of how much memory you can actually put on your motherboard. Right? First limitation is money. Right? Second limitation is whether or not you have the stuffs to handle it. The stuff such as motherboard capabilities as well as operating system capabilities. But anyhow, we have expansion slots where you can put expansion boards or expansion cards. Right? Needless to say, this is to expand what your motherboard can do. Right? Certain motherboards, even if you don't have the graphics or video card, graphics card. Right, so before we go on further with graphics card, I'll just tell you what that means. A graphics card is a circuit board that interprets, once you do something inside your memory, meaning once hopefully you still remember the fetch, decode, execute, store, right? This thing, control unit, ALU, right, and memory. Once you're done with that, you will have some kind of an output. But before you have that output, it needs to be interpreted first. Meaning these are like a list of numbers, and it needs to be interpreted before it gets to your output device, right? So if your output device happens to be a visual kind of device, like a monitor or a projector, then your graphics card will interpret that. Meaning all of these numbers will be interpreted into pictures, right? Something like that. Now, of course, needless to say, the more capable your graphics card is, the nicer your image or visuals or video will be, right? And the graphics card is one such expansion card. So if you get a better graphics card, that means you expand the capabilities of your computer better, right? So, sorry, we missed the main board writing. So this is the main board. Right, so this thingamajig is the main board. Anyway, some motherboard or main board already has a graphics card on it, so we call it onboard graphics. Right? And then some do not. Right, but most motherboards nowadays already have onboard graphics. People usually add more to have a better one, better looking graphics, like 3D and whatnot. Right. So anyway, back to expansion cards and expansion slots. Other things that we have on the motherboard would be the RAM slot, right? Random access memory. But random access memory is not the only memory that you have on the main board or motherboard. Actually, there are other kinds of memory. For example, we have read-only memory, right? And I'll tell you what these two means. Random access memory, for example, is volatile compared to this, which is permanent, right? So why would we want a volatile memory? We want a volatile memory because if we have a volatile memory, then the computer becomes flexible. We can install different things here, and when we need it, we can load it here. So that is important. To run things, you need something which is flexible and volatile. But there's a problem as well. When you switch off your power, boom, everything is gone. So that's where the storage and ROM comes into place, right? The storage will keep whatever software which is not necessary, application software, when you switch off your computer. Whereas read-only memory will store some very important stuffs, data and software which is absolutely necessary for your computer. These are technically system software. For example, things that will be in ROM is the BIOS, basic input output software, which will carry out the POS. POS is acronym for POS is acronym for, actually I can't really remember the POS. Self-test, power on self-test, sorry about that, right? So POS is power on self-test. Basically what happens is that a ROM is somewhere on the motherboard. It's a chip, we call it a ROM chip. So it's integrated, it's bolted onto the motherboard. So different motherboards have different ROMs, right? And on the ROM we have the BIOS, basic input output system. This is the first thing that will be loaded into memory once the computer gets switched on. You see, when you switch on the computer, it's like a black screen, and then you see some text, and then immediately you get Windows logo or something. So all of this little text is BIOS loading and doing the POS. What's the meaning of that? BIOS is basic input output system. It gets loaded, it checks whether the computer can work properly for the day. It's like, you know, the computer is so flexible. We have all of these expansion cards that we can take off and put in, and you can put different things, connect it, and then switch it on again. So every time the computer wakes up, it needs to test whether it has all of the necessary organs to work for the day. It's like a human being going to sleep, and we can pull off his arm and stuff. And so when he wakes up, he needs to know whether he can function properly for the day. So this is necessary, and so this is put inside a permanent memory, which is on the motherboard rather than away from the motherboard and connected by a bus, data bus. It is put on the motherboard, and that is a read-only memory, and it's permanent, right? Read-only memory, there's several versions of read-only memory. You can refer to your slides. We have read-only memory, and then programmable read-only memory, and then we have electrically programmable read-only memory, and then we have electrically erasable programmable read-only memory, right? Oh, sorry, this is electrically programmable, erasable programmable, electrically programmable and electrically erasable programmable read-only memory, and then we have flash. Okay, we've learned about RAM and CPU, and you know, in the first week we learned it something like this. It's like, this is CPU, this is RAM. It's like they are so close together. In reality, RAM is roughly 30 times slower than CPU, right? Or maybe I should negative 30 times slower than CPU, meaning RAM is much slower than CPU. Imagine if RAM is working or running at 5 kilometers per hour, right? CPU will be going at 150 kilometers per hour. Now if you imagine a road like this, you imagine that people or cars in this road will never get to that road because it's just too fast, and there's a disparity here. So that means that, you know, fetching and writing back or storing to RAM, you know, the whole fetch, decode, execute, store thing, there will be a problem here because there's a great disparity in speed. So to rectify that, to take care of that, we have things called the cache, right? So this is like the intermediary lanes. Before you go from the slow lane to the extreme fast lane, right, you get the intermediary lanes, and basically it goes like this: L3, L2, L1 CPU, right, and then RAM. So this is in terms of speed. RAM will be slowest, and then followed by L3, L2, L1, and CPU will be fastest. Some CPU have L1 on the CPU and L2 on the main board. Some CPU have L1 and L2 on the CPU, so you will have L3 on the main board but close to the CPU, right? And so these are the different types of memory. We have random access memory, right? And then faster memories, we have cache L3, L2, L1, and then we have permanent read-only memory. Of course, within the CPU, we also have the register. These are extremely fast memory as well, right? And so those are the kinds of memories that you have inside your computer.